This is Algebra 2, Lesson 2.1, Explicit Arithmetic Sequences. So we've already been talking about arithmetic sequences, and that is a list of numbers. That would be a sequence. The arithmetic portion of it is that it changes through addition. Now remember, we can always add a negative number, and that's really the same thing as subtraction. So we have a common difference in an arithmetic sequence. We're going to add 2 over and over again, or we're going to subtract 7 over and over and over again. So that common difference, the number that changes by, we were using the letter D to represent the common difference. And to obtain that, if you take the second number and subtract the first number, that will tell you what it changes by. So sometimes that's pretty obvious in the list 2, 4, 6, 8, 10, 12, etc. We know that it's going up by 2, but something less obvious like 2.7, 4.9, etc. we can subtract the second number minus the first number to see what it changes by. And we've already been talking about recursive formulas, starting with U0 or U1. And UN is UN minus 1 plus the common difference. So in the past, if I wanted to find the 10th answer, I would put in my start, add my difference, and hit enter 10 times to get to the 10th answer, which is doable. It's not difficult, but if I wanted to get to the 50th answer, the 100th answer, it becomes a little tedious to have to hit enter 100 times. And that's where the explicit formula comes in. Rather than repeatedly adding, we can use multiplication, which is repeated addition, in a single step rather than multiple steps. So again, we need that starting number, and we have that common difference, and however many times we need to add that number, we just substitute the value of n, and that tells us the 10th answer, the 100th answer, the 50th answer, etc. So, scrolling down to some examples. Letter A says, find the indicated term. So I have a explicit formula here. Sequence AN equals 4.2 plus 5n, and it asks me to find a sub 0. Well, that's the 0 term, which is already in the formula here. So really the answer is just 4.2. But if I wasn't sure, I could always substitute the value for n into the explicit formula. 4.2 plus 5 times 0. 5 times 0 is 0. 0 plus 4.2 would still be 4.2. I can find A1, again, recursively or explicitly. Recursively, I know that I'm starting at 4.2 and I'm just adding 5. So that would be 9.2. But explicitly, I could substitute 1 in for n of the expression 5 times 1 is 5, 5 plus 4.2 is 9.2. So the 20th answer is doable recursively. I have to add 5 and then add 5 and then add 5 and then add 5 20 times, but this is an example that will be much easier explicitly. I just have to substitute the 20 in for the n of the expression. 5 times 20 is 100. 100 plus 4.2 is 104.2. Letter B says C sub 1 is 12, C sub n equals C sub n minus 1 plus 4. So I have a sequence that starts with 12, and then I'm adding 4, and then adding 4, and then adding 4, etc. So I did this answer already. C2 is the second answer, and if this is my first answer, this would be my second answer. So I already know the second answer. But that 0 answer, this is the first and the second and the third and the fourth. The 0 answer would be the number in front of the 12, but keeping to this pattern. So since I added 4 to go up the pattern, I just want to subtract 4 to go backwards. So 12 take away 4 is 8, and that would be my 0 term. So now that I know the 0 term, and I already knew the common difference, finding the 20th term can be done using the explicit formula, the 0 number plus the common difference times 20. And I'll write that to the side just so that we know we had the 0 plus the common difference times n. That's our explicit format. 4 times 20 is 80. 80 plus 8 is 88. And I shouldn't be switching letters since this is C. I want the C there. Okay. Example B, consider the sequence 4, 7, 10, 13, etc. Write an explicit formula. So this is my first term, my second term, my third term, my fourth term. If I want to figure out what it's changing by, I can count, but if that's not super obvious, if we take the second number minus the first number, we know that it's going up by 3. So the 0 number would be the number in front of this 4 in this pattern. So if I do 4 minus 3, it tells me the number in front of the 4 is 1. So now I can write my formula. U sub n is the 0 term plus the common difference times n. I'm going to use that formula to find the 15th term. So to find U15, I just need to substitute 15 in for the n. 1 plus 3 times 15. 3 times 15 is 45. 45 plus 1 is 46. Example C. Consider the sequence u sub 0 is 42, u sub n equals u sub n minus 1, minus 5. Write an explicit formula. Again, I need two things. I need this u0 and I need the d. And this formula written explicitly, recursively, already gives me that information. I already know the 0 term is 42, and I already know the common difference is that it's subtracting 5. So my u sub n formula would be u sub 0 is 42 minus 5 times n. Now I can write plus negative instead of minus 5, but minus 5 is, I think, simpler, so we want to keep this in simpler terms. If I want the 15th term, I just have to substitute 15 in for the n. 5 times 15 is 75. 42 minus 75 is negative 33. I have one final example, a word problem. Letter D, Paula needs to have her dishwasher repaired. The parts cost $52 and the service technician charges $25 per hour. If it takes 4 hours to complete the repair, how much does the repair cost? So we're going to talk about this in terms of our explicit arithmetic sequence. The 0 term is $52 because there's a $52 initial charge. The common difference is 25 because every hour that we add to the repair adds $25 to the repair charge. So our explicit formula would be u sub n is 52 plus 25n. And if this specific repair took 4 hours, we would do 52 plus 25 times 4. 25 times 4 is 100. 100 plus 52 is $152. That is it for the notes. Good luck on the exercises, and please let me know if you have any questions.